Hello and welcome to our discussions on duals in linear problem. Now, in previous few lectures, we have seen what is the relationship between a dual and a primal. The main problem that we are provided with is called a primal. It is a primary problem. From that primary problem, primal, we can formulate a dual. In previous lectures, we have seen what kind of relation do they actually bear and what kind of relationship they bear mathematically. Mathematically, they bear a relationship of transpose. And actually, they bear a relationship of changing the perspective. From producer of something, if I become supplier of something, things change. If I'm supplying, I try to reduce my cost. But if I'm producing something, I try to maximize my profits. So there is a shift in perspective that we have talked in previous questions, where I suppose there was a question where I was making use of labor hours. Now, if I become a supplier of labor hours, then I would wish to make a profit from those labor hours. But if I am a producer, I would try to minimize consumption of labor hours. I would try to reduce the consumption. I would try to reduce the cost associated with labor hours. So that is a shift in perspective that we have talked in previous questions. Today we'll try to solve a dual and see what is the relationship between the slack variables, the decision variables of primal and dual. So for the purpose, we'll be taking a very simple problem. Why are we solving it through a dual? We have seen in previous lectures. Why we need a dual? We have seen in previous lectures. Today we'll only see what is the relationship between the simplex tables of a primal and a dual. So we'll take up a very small problem and try to solve it using dual. So our problem goes like this. Z max is equal to 10x1 plus 12x2 subject to three constraints. Those three constraints are 2x1 plus 3x2 less than equal to 1500. Then there is 3x1 plus 2x2, 3x1 plus 2x2 less than equal to 1500. Then there is third constraint which says x1 plus x2 should be less than or equal to 1000. And of course, x1 and x2 are greater than or equal to 0. So this is the primal that we have been provided with. How to formulate a dual of this problem? We have seen in previous lecture, but we'll again see it over here, how I can convert this primal into its dual. What is the method? I prepare a table. x1 and x2. x1 is 2, 3, 1500. I'm taking up these constraints 2, 3 and 1500. 3, 2 and 1500. Then there is 1, 1 and 1000. Then there is Z max and 10 and 12 giving me Z max. Now we can see that it is a very beautiful pure canonical form, max less than, no problems at all. So I can directly formulate a dual from it. My dual would be, I put up my new dual variables over here, y1, y2 and y3 and formulate a relationship from here. The relationship would be 2y1 plus 3y2 plus y3. 2y1 plus 3y2 plus y3, and this time it was less than, so now it will be greater than 10. 2y1 plus 3y2 plus y3 greater than 10. Next would be 3y1 plus 2y2. 3y1 plus 2y2 plus y3 would be greater than or equal to 12. And finally, this was Z max, so I will be having a Z min from here, 1500 y1 plus 1500 y2 plus 1000 y3, and of course y1, y2, y3 all have to be greater than equal to 0. So this is primal and this is our dual of that given primal. Now with this dual, I can start solving it. Let us go ahead and search for its standard form. This is canonical form. For solution for IBFS, we need to convert it into standard form. That standard form would be 2y1 plus 3y2 plus y3. Because this is greater than, I will be having a surplus variable, and with every surplus there comes an artificial variable is equal to 10. This would be 3y1 plus 2y2 plus y3 minus s2 plus a2, because this is again greater than 12. And now because you have some new variables s1 and s2 and a1 and a2, we need to incorporate them into objective function also. So my objective function becomes zmin is equal to 1500 y1 plus 1500 y2 plus 1000 y3 plus 0 s1 plus 0 s2. It is minimization. So I will be having plus m a1 plus m a2. This becomes my objective function. And if I try to find out IBFS from this, it will be y1 is equal to 0, y2 is equal to 0, s1 is equal to 0, s2 is equal to 0, a1 is equal to 10 and a2 is equal to 12. Now I am not talking of all the steps because I assume that you understand how to solve a linear problem. This is a case of minimization. We have certain greater than inequalities. So whenever there is a greater than inequality, you make use of surplus variables. With all surplus variables, you'll always have an artificial variable also. I'm assuming that you have gone through the earlier videos and you know how to convert primal into dual and solving that dual, converting the canonical of dual into standard of dual, from that dual reaching the IBFS. This is my IBFS. So I assume you are well versed with these steps. Today what we are seeing is what is the relationship between the final simplex table of a dual and final simplex table of a primal. So that is what we are trying to learn today. As far as this is concerned, you can check out our previous 2 videos. You can go through the steps. Now, once I have my IBFS, let me go ahead and solve this. We have a b and a theta. And there are a lot of variables this time. We have a1, a2, s1, s2. And there is a y1, y2, y3, y3, y2, y1. What are the contributions? 1500, 1500, 1000, 0, 0. 1500, 1500, 1000, 0, 0. Minimization giving me a plus m. This is big M method. What is the IBFS? A1 is equal to 10, A2 is equal to 12, A1, A2. A1 is equal to 10, A2 is equal to 12. What are contributions of A1 and A2? Contributions are M. Let me put these constraints over here. We have a 2, 3, 1. 2, 3, 1. Next one is 3, 2, 1. 3, 2, 1. Then there is minus 1, 0, 0 and minus 1. Then there is a 1, 0, 0 and 1. Here we have Cj and Zj. So let us go ahead and find out our Zj. Zj is some product of respective column with contributions. So 2m plus 3m, making it 5m. This again becomes 5m. This becomes 2m. This will be minus m. This again is minus m. We have a m. We have another m. Now, this being minimization, will not go for Cj minus Zj, rather will go for Zj minus Cj. So, Zj minus Cj. Zj minus Cj would give me 5m minus 1500. 5m minus 1500. Again, it will be a 5m minus 1500. This will be a 2m minus 1000. This will be minus m, 0 and 0. So, when we talk of these terms, which one is most positive? We see that last two are 0, these two are minus m, negatives. So, these four are no good. 2 are being rejected on basis of 0, 2 are being rejected on basis of negative. What about these terms? What are these terms? These two are similar. So, we will talk of them. 5m minus 1500 and then there is a 2m minus 1000. Which of these two is larger? We need most positive. Which of these two is larger? What is m? If you remember from our previous videos, m is a very large positive number, larger than any of these numbers and very, very large as compared to any of these numbers. Let us say it is 1 lakh. So, in that case, this becomes 5 lakh minus 1500, almost equal to 5 lakh. This becomes 2 lakh minus 1000, almost equal to 2 lakh. So, who is more positive? This is more positive. So, I will stick with 5m minus 1500. Now, both of the values are 5m minus 15. You can go with any. Let us go with first one itself. Now, because both are same, we can go with either of these. So, we have our key column. Key row would be decided by 10 divided by 2, giving me a 5. 12 divided by 3 would be a 4. So, let me go with this one. This giving me my key row. Now, this is an iterative process. If instead of y1 you go with y2, there is no harm. In next table, the values will be optimized. If we are going with y2 in this case, if you decide to go with y2, you will see that after a period of 2 tables, this is my first table, I prepare a second table, you also prepare a first table and you also prepare a second table. After a matter of 2 tables, our values will be similar. Because it is an iterative process, it keeps on improving itself. Even if we make a wrong choice right now, it will improve upon in the next table. So, I am sticking with this one. So, this is my key column, key row and key element. This is our table 1. Let us prepare our table 2. Now, who is outgoing? A2 is outgoing. So, from new table onwards, we will not be having any mention of A2. We will only be having Y1, Y2, Y3, S1, S2, A1, B and theta. Because A2 is outgoing variable in first table, now we will never talk of A2. A2 has been kicked out. A1 is still over here. Instead of A2, we are having Y1. What are their contributions? 1500, 1500, 1000, 0, 0 and M. Contribution of A1 is M, Y1 is 1500. Now, this is our key row. Bring this key row over here. How do we bring key row to new table? After dividing it by key element. Divide all these values by key element. 3 divided by 3 would be a 1, 2 by 3, 1 by 3, 0, minus 1 by 3. This would be a 0, 12 by 3 would be a 4. Remember, A2 is being rejected because whenever an artificial variable becomes outgoing variable, we reject it from further calculations. So once A2 has been outgoing, we have rejected it from our further calculations. What about this second, first column rather? First column would be, or first row, sorry, old row minus key column element I multiplied by modified key row is equal to new row. First row is 2, 3, 1, minus 1, 0, 1. I am removing A2. I am not talking of A2. I am not considering A2. And then B would be 10. Minus key column element. We are talking of first row. So key column element first. This is key column element first is 2. Multiplied by modified key row. Where is our modified key row? Here is our modified key row. Now I am not taking these steps in detail because we have already talked about these steps. Today we are just learning what is the relationship between the tables of primal and dual. So this will be a 2 minus 2 making it 0. This will be a 9 minus 4. 5 by 3. Wow, this will be 3 minus 2. 1 by 3 minus 1. 2 by 3, 1. 10 minus 8 would be a 2. Giving me my table as 0, 5 by 3, 1 by 3, minus 1, 2 by 3, 1 and 2. I'll just check it quickly if the values are correct. The values are like 3. Perfect. And 2 by 4. Perfect. So these are my values. Now let me go ahead and find out Cj minus Zj. Zj would be 0 multiplied by m 0, 1500. This would be 5m by 3. 5m by 3 plus this thing 3, 500 plus 1000. This would be m by 3. Sorry. M by 3 plus 500. Then we have a minus m. This would be 2m by 3 minus 500. And finally, we'll be having m. I'll be going with Zj minus Cj. Why Zj minus Cj? Because this is a minimization problem. Though the original problem was maximization, but the dual suggests Zmin. So for Zmin, I'll be going for Zj minus Cj. 1500 minus 1500 would be a 0. 5m plus 3 minus 5m by 3 plus 1000 minus 1500 would be a 5m by 3 minus 500. And then this would become m by 3 minus 500. This will be minus m. This will be 2m by 3 minus 500 and this will be a 0. Now if we monitor all these values very carefully, this is a 0. No further participation, no further possibilities. This one is a minus m, no further chance. If we talk of these three, these all are not clearly negative nor clearly positive, neither clearly positive. So this way, this one is 5m by 3 minus 500. This is m by 3 minus 500, and then there is 2m by 3 minus 500. These are the three values which we need to decide upon which is the most positive. Now clearly, because m is very large positive integer, these will literally be having no issues. This is literally equal to 5 lakh upon 3. This is almost equal to 1 lakh upon 3, and this one is almost 2 lakh upon 3. So all these values are being divided by 3. This 500, 500, 500 is negligible. Either ways it is common to all. So we can reject it, leave it. Everything is being divided by 3. So which one is the most positive? This is most positive, thereby giving me my key column. And if I divide B by key column, I will get my key row. 2 divided by 5 by 3. 2 divided by 5 by 3, making it 6 by 5. And this one would be 4 divided by 2 by 3. 4 divided by 2 by 3, making it 12 by 2, that is 6. So this is 6 by 5, this is 6. So this will definitely be smaller. So this time A1 is your outgoing variable. If A1 is your outgoing variable, you have your incoming variable as Y2. I told you, even if we make a slightly improper choice, next time it will get rectified. If you had taken Y2, this time you would have gone with Y1. I selected Y1, now I am going with Y2. And we can even tally our tables after this calculation. So this is our second table. Now we need to prepare our third table. Third table I'll try to put up over here itself. Let us see if we have some space. Y1, Y2, Y3, S1, S2. Now there will be no A1 because A1 is outgoing variable. A2 was already rejected, A1 is now freshly being rejected. So we are free from artificial variables. We have our B and thetas. We have contributions as 1500, 1500, 1000, 0 and 0. The variables in our table are A1 is being replaced by Y2. I have Y2 and Y1. And contributions of Y2 and Y1 are 1500 each. Now, we have our key column. We have our key row. Let us transfer this key row to new table by dividing it by key element. We have our key element. So 0 would remain a 0. This would become a 1. 1 by 3 divided by 5 by 3 would be a 1 by 5. This will be a minus 3 by 5. And then S2 would give me 2 by 3 divided by 5 by 3, making it 2 by 5. And last one would be 2 by 6 by 5. Fine. And then second row, we'll make use of that formula. What is that formula? Old row minus key column element. We are talking of second row, key column element 2 multiplied by modified key row. What are the elements? 1, 2 by 3, 1 by 3, 0, minus 1 by 3. This 0 I am rejecting because it belongs to artificial variable. We are not talking of any artificial variable. We rejected A2 earlier. Now we have rejected A1 also. Minus key column element 2, which is 2 by 3. Here we have it. 2 by 3 multiplied by modified key row. Modified key row is, here we have it, 0, 1, 1 by 5. This minus would come here, 3 by 5. We have a 2 by 5 and last one is 6 by 5. What do we have? 1, 0. This will become 5 minus 2, making it 3 by 15. 2 by 5. This will be 5 minus 4, minus 5 minus 4, making it minus 9 upon 15. And last one would be 15 fours are 60, 60 minus 12 would be a 48 upon 15. I get my values as 1, 0, 3 by 15, 2 by 5, minus 9 by 15, and last one is 48 by 15. And now if I try to find out Zj, so Zj's would be 1500, 1500, 500 and 100, 300, 800. Then this would be 300 minus 900, minus 900, 600, minus 900 and 600 would be a 300. And last one would be 300, 600 minus 900. Then we'll have Zj minus Cj. Zj minus Cj because it is Zmin. Zj minus Cj will get a 0, 0, minus 200, minus 300 and minus 300. Now because all these values are either 0 or negative, we reach our optimum solution. But that's a catch this time. The catch is that we had to solve this value. I had to give my decisions in terms of x1 and x2 and maximize z. But what I have done is I am giving my decisions in terms of y1 and y2 because I have not solved the primal, rather I have solved the dual. So I am getting these values. Now there is a relationship between these primals and duals. x1 and x2. Now if we see this equation once again, if we go to the table once again, we'll see the relationships. The table that we used to formulate the dual was 2, 3, 3, 2, 1, 1, 1500, 1500, 1000, it was 10, 12, Z max. Now if you remember, we had 2 variables and 3 constraints. This time I am having 3 variables and 2 constraints. I have 3 variables and 2 constraints. So 2 variables has been converted into 2 constraints. 2 variables have been converted into 2 constraints. If there were 7 variables, they would have been converted into 7 constraints. And what each constraint does is, each constraint gives me an S, a value of S. It could be a slack value or it could be a surplus value, depending on whether we are minimizing, whether it is greater than or less than. But each constraint gives me a value of S. And I was actually having 7 variables. So 7 variables of primal become 7 constraint of dual. 2 variables of primal become 2 constraints of dual. 2 variables of primal have become 2 constraints of dual. Therefore, each dual will give me a slack value and answer will be under that slack value. This is my answer. My answer to primal always lies under constraints of dual. What can I write? Value of decision variable is available under slack or surplus, as the case may be, as inverted. Value of decision variables, x1 and x2 are decision variables. Value of decision variable is available under slack surplus. Value of decision variable of dual of primal. Value of decision variables of primal is available under slack surplus of dual. This is the relationship. This is what we were studying today. That what is the relationship? I was asked to find out values of x1, x2. Instead, I am giving values of y1 and y2. What is this? It is not like this. When you have solved this complete problem using your dual method, this was our first table, second table and third table. Your decision variables x1 and x2 will be available under respective slacks. S1 will be available under S1. X2 will be available under S2 in inverted form. So this is minus 300. So now I can say that x1 is equal to, in inverted form, x2 is equal to whatever you are getting under S2, 300. Why this symmetry? Because the table exactly gets flipped. If you have 3 variables, you end up with 3 constraints. If you have 7 variables, you end up with 7 constraints. I had 2 variables, I end up with 2 constraints. And each constraint gives me a S value. And under those S values, I will be getting my original decision variable values. S1 is minus 300, so I can say that x1 is actually 300. Where will you find x2? You will find x2 under the slack of dual. Second slack of dual, that is 300. And of course, it will be in inverted form. If you are getting minus 300, it means it is actually in 300. So I have my x1 and x2. Can I have z max also? Z max is equal to 10 x1 plus 12 x2. 10 x1 plus 12 x2, making it 10 multiplied by 300 plus 12 multiplied by 300, making it 3000 plus 3600 is equal to 6600. So this is the relationship between primal and dual. That whatever is slack over here is actually decision variable of primal. So if you are given a question that solve the following problem using dual, so this is solution using dual, but my answer is not y1 is equal to 48 by 15 and y2 is equal to 6 by 5. Rather my answer is x1 is equal to 300 and x2 is equal to 300, giving me a z of 6600. This is the relationship between primals and duals. So with this we conclude the dual relationships. We have seen what is the relationship between dual and primal. We have seen how to convert a dual into a primal, and we have seen what is the mathematical relationship between the simplex tables of dual and primal. So this is it for our today's discussion. Until we meet next time with a new topic. Thanks for watching. Bye-bye. Take care.